In this video, I'm going to show you two things. So first off, I'm going to talk to you about how you can assign value labels, or in SAS they're called formats. Then I'm going to show you how to run basic descriptive statistics like means, frequencies, correlations, and so forth. So let's start out with value labels or formats. I've got an SPSS data set up, and if you go to the variable view, remember that this column called values allows you to assign value labels to a variable. So for example, this topic all variable has a value of 1 corresponding to sharing mileage saving tips. The value 8 is associated with mommy moments. So when I go over to the data view, what you'll see is that if we look at that variable, these meaningful labels show up rather than the numbers. All right, so how do we do that in SAS? The answer is we're going to use formats. So let me just refresh your memory why this is a good idea. So you don't really want to have the word married or single or divorced or any other string literal like that in your data set for a couple reasons. First off, people are going to mistype it. So not everyone will spell married right. Maybe they spell it capital M one time and lowercase m the next time. Capital M married and lower m married are two distinct values and would show up separately in a frequency distribution. So you'd spend a whole lot of time cleaning up your data if you allowed people to just type in a string literal like married. So it's much better to just store it as a 1. Another reason is that the 1 uses up less space in a file. So, a 1, 2, 3, 4 would take up 1 byte, whereas married, single, divorced, widow would take up to, 8 bytes. And so the files can become larger. So for those reasons, it's better to use a number. So how do you assign these value labels or formats? The answer is with PROC format. So PROC format allows you to assign these. Now, after you start PROC format, you can have one or more value statements. So let's look at the value statement. So value is a reserved word. Then SAS expects some name for a format. So I'm going to use mstat. I can use any name I like, any valid SAS name I like. I could call it applesauce if I wanted, and that would be fine. Then I list all the values, followed by an equal sign, and then the string literal in quotes. Then I end up with a semicolon. Now I could add another value statement if I had another categorical variable here. I don't in this particular example, so I'm going to stop and just say run. Now I'm going to read in a data set, and in this data set, we'll learn how to read in data sets in the next lecture. But the key thing is I've got a format statement in here. This format statement is going to associate the variable mstat, so this is the variable mstat, with the format mstat dot. So formats always have a dot in them. Variable names never have a dot in them. So if you think about the formats that we learned about last time, we had things like $8.2, or we had 4.3 would be something that took up 4 spaces with 2 decimal places. So they all have a dot in it. So this is the variable mstat, this is the format, and it's okay to call them by the same name. Now if I run a PROC contents on this data set that I just read in, what you're going to see is that this mstat variable now has a format associated with it labeled mstat dot. If I print it, what you will see is that it doesn't print out 1, 3. It prints out customer 1 is divorced, customer 2 is single, and so forth. Customer 4 is married. Now, if I wanted to get rid of the format, so this would be something like in SPSS, when I go back to SPSS, if I go up to view value labels, you can't see it because it's at the top of my screen, but I'm clicking at view value labels. That turns off the formats. So how would I turn off the formats in SAS? Well, I would simply say format, mstat, and then I want to print this as a single digit numerical value. I don't want to print my mstat format with it. So when I execute this, then I get to see one count, 1 3 2 2 and so forth. Now what I've just done is to create some formats, and they're going to vanish as soon as I exit SAS. And I probably don't want that. So usually I want to save these formats. In SPSS, the formats are saved in the same file as the data itself. In SPSS, they are, in SAS, we save them in a separate data set. So if you want to write these formats out into a separate SAS data set, you use this control-out equals command, and then you have to give it a valid library and then some data set name. So cur.formats is going to create a SAS data set called fmts in the current directory. So here we've just associated mstat with that. Now in the future, what you would do is include this stuff at the top of your program. So you would put proc format, cntln reads all those formats into SAS, so that when I run a frequency on this, you'll see that the marital status then has the correct format with it. Sometimes you want to just get rid of all formats. Sometimes you, for a number of reasons. Sometimes you don't have the format file and SAS complains if it can't find it. If you say format underscore all, that just says, don't worry about user-defined formats. Let's actually, here's how you do value labels in SPSS. So you've got pretty similar syntax. It almost looks identical to what you have in SAS, except you don't have an equal sign. And yeah. All right, let me run an example with you now. I'm going to go over to Harden, and we've got this data set Siegel. I'm going to go edit that Siegel thing that we had before, so we'll VI it. And here is that data set. Let's say that I want to create some formats for the female variable. So to do that, I need to add a proc format somewhere above that PROC. So if I say, I'm going to open up a new line, so little o, then I'm going to say proc format, semicolon, and then remember I've put some formats in here, so value, and I need to give it some meaningful name. I'll just use female because that's the name of the variable. It helps me keep track of it. And now I need to type in the values. So 0 was male, 1 is female, and then we have to end the value statement, and then we'll run. Now I've just entered all that. I'll hit escape to get me out of insert mode. Then I need to add this format to proc. So to do that, I'll hit capital G to take me to the end of the file. K moves me up a line. I'm going to open a line with capital O, 2 spaces, indent, format, female dot. Now, just for fun, I'm going to run this twice. So I'm going to do a left curly brace. I'm going to yank a paragraph. So Y, right curly brace, it yanks 5 lines. Then a capital P. I'm going to go down 3 lines to format and delete that line. So we'll run it once with the format and once without the format. Let's write it, let's quit, and now I'll SAS it. So SAS Siegel, and then we'll VI all the files at once. It's going to take a second. 2 seconds. Okay, we'll search for errors. SAS is happy. If we do a page down, that's a control F. You'll see that proc format has output a format female. and it looks like everything's fine. I'll do :n to get to the next file. I'm going to do a cap G to go to the end. And so what you'll see, here's the first time I ran proc format. Proc freq, and female shows up as 0s and 1s. If I do a Control F, here is where we have male and female showing up with those meaningful labels that I gave it. So notice the values are the same. We have 28 females, 43 men. It's just that in the bottom one we have meaningful labels. So that's how we get these meaningful labels in. One more thing. Maybe I want to write this format file out. So remember how I do that? I'll go to the end of format, hit insert, cntl out, and then cur.fmts will create a format file. Now I've got a little problem because SAS is not going to know what cur means. That libname has not been assigned. So let's assign a new library. Libname cur. Let's write it. I'll bring up the command again, run it. And if we go to the file, you'll see, yes, sure enough, we have those formats. I'm going to get out, and let's do an ls. What you'll see is that there's a new file out here called formats.sas7bdat that has all these formats in it. And I just created that. Okay, so that's how we make formats. Let's move on. I'm going to give you a little bit more detail on descriptive statistics now. So how do you run a frequency distribution? PROC freq. Well, we've just done that. A few things to note about it. In the tables command, you can list as many variables as you like. So here I listed color and X from that little MyData data set that we created a couple videos ago. And so we get two frequency distributions. Here's the equivalent syntax in SPSS, and it looks pretty similar. Instead of tables, you use variables. How do you run a crosstab in SAS? Well, in SAS, you continue to use PROC freq, but you put a star operator between the variables. So color star X is going to put colors in the rows, X in the columns. In SPSS, you use the crosstabs command. I'll show you a few more tricks. So very often you'll want to profile some variable, like segment membership, against a bunch of other variables. So rather than saying, segment star marital status, segment star gender, segment star race, what you can do is just put them all in one statement. So if you say color star and then list a bunch of variables in parentheses, the color gets distributed across those and you get a table for each one. So there's the table for X and then table for Y, I guess I omitted. The other thing to note is that you can add a lot of options. So PROC freq is another Christmas tree and you can hang all sorts of ornaments around it. Here are some of the most commonly used options. So no col suppresses the column percents, no row suppresses row percents, no percents suppresses the joint probabilities. Deviation gives you the unstandardized residuals in SPSS, so that takes observed minus expected. Chi-square gives you the chi-square test. And so I've listed exactly what those do down here. Let's move on to descriptive statistics. So the equivalent of descriptives is PROC means. We've already seen this, and I'm going to add, we've already seen the var statement in one of my previous examples. You don't need the var statement. If you just say PROC means, it runs it on all the numerical variables in your data set. If you give the var statement, then it only runs descriptives on those two variables. As with SPSS's descriptives, by default you get 5 descriptive statistics. So n, mean, standard deviation, min, and max. You can control which statistics are printed by adding options after the data step. Well, anywhere in the PROC mean statement. So if I just wanted n, mean, max, and the standard error, that's how I would do it. Here's a whole list of of some of the valid options, there's actually more. So SAS gives you just about every descriptive statistic you can think of, including the coefficient of variation, which you can't get very easily in SPSS. And you can't get any of the percentiles in SPSS as descriptives. You have to go to explore in SPSS. Now, how do you do the equivalent of SPSS's compare means? So compare means is where you compute the means or other descriptives by some other variable. Well, in SAS you can do it in one of two ways. You either use a class statement or a by statement. So either one will work. Let me show you what you get, and then I'll talk about the difference in a second. So if you say PROC means data equals whatever your data set, this time I'm going to look at that California Pizza Kitchen data set, n and mean. I only want those two statistics. Class Q16 means I want to break this out by gender, and then the variables will be Q1, Q2, and food. All right, so what this is going to do is break out, here are the results for males, here are the results for females, we have the means of those three questions, the overall experience, and so forth. So that's just like compare means in SPSS. Now, what's the difference between class and by? The difference is simply this: if the data is already sorted by some variable, then you can use by. With class, the data doesn't have to be sorted ahead of time, so you can avoid that sort. That's the main difference. That's about all I care to talk about at this point. Now, one of the most useful combos, I think, in SAS is that you can use PROC format to group values that appear in a crosstab or PROC means. So let's say I have something like the number of times that someone has made a previous order. So this is a count variable, but most of the values are ones, and then there's a fair number of twos, and then we have a very long tail. So here's another thing that I can do with PROC format. I can make a value, call it ords, this format. 1 is going to be associated with 1, 2 will be associated with 2, then 3 through the highest value will be associated with 3 plus. All right. So if I run a crosstab, here's this tote ord against target act as a 0-1 variable, indicating whether or not they bought from a particular offer. The trick is I'm going to add a format statement. So I'm going to display tote ords with ords dot, that format I just defined. Now you see I only have 3 rows in my crosstab with the 2 columns. I could also slap that format onto a PROC means, and so we'll do a class with the tote ord. Here's that format, and you'll see that we have 3 lines showing the mean, min, standard deviation, and counts for each of the 3 values of tote ords. Now, let me emphasize the beauty of this. So in SPSS, the way you would do this is with the recode statement. You'd have to recode all values 1 staying 1, 2 staying 2, and then 3 through high would get assigned to some other value 3, and we'd have to go assign a value label to it. In order to do that recode, you're going to have to take a pass through the data. You're going to have to go all the way through the data, then you have to go all the way through the data again to run the frequencies. The beauty of SAS is that you only need a single pass. So you assign this format, you run the freq, you take a single pass, and so it's computationally much more efficient. Now, if you only have 100 cases, who cares? But if you have 10 million cases, taking a pass through the data requires substantial time. So this is a really good thing to know about. Another thing that you can do with these various PROCs is, instead of sending the output to the screen, you can send it to a file. Or in addition to sending it to the dot list, you can send it to a file. In SPSS, you did this with the aggregate command. So PROC means is kind of like descriptives and aggregate all rolled into one. So let me give you a little example. This was that code that I ran before. For example, I want to compute the means of questions 1 through 3 by gender, or class gender. And so if you run this, this is what you get. I've added an additional statement though. So that's an output statement. So let me translate what this is going to do. So output says this. Out equals, I want to make a new file, new data set called temp, and that's going to live and work. And in that file, I want to store all the means. So means equals, we'll store those means. Then I'll print this. We'll slap a format on, so we'll display all these as 4.2. And down below, you get to see what the output looks like. So I'm going to have one row for every value of the class variable, so male, female. I also have this first row where Q16 is missing. And what that really means is it's the overall, so it's males and females combined. And you can see that with the freaks. You add these two things up, you get 14,800 and something. Now you have all the means. So you'll see that 4.26 is the mean of Q1 for males. That matches up with what you had in PROC means. Likewise, 4.31 is the mean for females, and that matches up exactly here. 4.29 is the grand or overall mean for question 1. Okay, so you've now stored this in a file just as you did with aggregate in SPSS. Couple options that you may want to know about. Sometimes you don't want this first row, you don't care about the grand means. So to get rid of that, you're going to specify an n-way statement. Sometimes you don't want to look at the output, you don't want to send it to output, so that would be completely like aggregate, where aggregate just sends stuff to the a new data set. So to suppress this output up here, you use the no print option. Now, PROC means no print is such a commonly used thing that SAS has created another PROC called PROC summary that is identical to PROC means no print. So PROC summary is identical to aggregate in that sense, that it only sends stuff to an output data set. I'll give you a few more details about this. So remember, in aggregate, you can choose what descriptives you want to compute, whether you want the max, or you want the mean, or the counts, or the sum. Here's some things that you can do with PROC summary. So I've added another class statement. We've added the n-way to get rid of all those, the grand means. Here's how we get rid of the type variable. So if you add this drop type underscore, remember that type variable was this thing on the previous page that said, well, type 0 is grand means, type 1 is the marginal means for means and females, males and females. All right, so here's the output that you get. So no type variable. A few more options. So let's make it a little bit more complicated. So here, output, out equals temp, we'll drop the type variable. Now let's just say I wanted to find the means of Q1 and Q2, and I'll call that mean Q1, mean Q2. Then let's say I want to find the maximum value of Q2 and Q3. Don't care about the max of Q1. We'll call those max Q2, max Q3. And you'll see below is what we get. All right, so you probably want to practice that on your own. Let's move on to PROC univariate. So in SPSS, you have descriptives, and that does simple descriptives. By simple, I mean stuff that you can do in a single pass, like means and standard deviation and skewness. Then in SPSS, you had another procedure called descriptives explore, where explore did a lot of other stuff that was more complicated. So anything requiring a sort is more complicated. Things like finding percentiles, creating box plots, histograms, and so forth. Okay, so descriptives explore did all those other things. The equivalent in SAS is called PROC univariate. Here are a few useful options. So plot will give us a box plot. Normal will give us normal probability tests, just like in Descriptives Explore, we got a normal probability plot and the tests of normality. Just like Descriptives Explore would give us a trim mean. If you want to trim mean in SAS, you use PROC univariate with the trimmed equals option. You can also get a Windsorized mean if you want. So here's univariate. PROC univariate, here's a data set. We'll put the plot option. The ID option, like with PROC print, identifies records with that variable name. So here's the output. You'll see you get a full array of different descriptive statistics. Here's all your percentiles. Here's your range, your interquartile range, your mode. Here's the box plot. It's a text box plot. It also shows these extremes. Now this is caused by that ID statement. So the ID statement specified a newspaper name, NP name was that. And so what you'll see is in these extremes, the highest was 208, which was Bluefield, West Virginia, I think. Actually, it wasn't the highest. Chicago was the highest with 297. Bluefield was the 5th highest. Austin was the lowest with only 72 values. All right, so that shows up there. So when I run descriptives on your midterm exam, I copy your last name so that I know, who had the highest score, who had the lowest score. How do you run correlations? Well, you run correlations with PROC core. PROC core looks a whole lot like PROC means. You give it a var statement, list all the variables that you're interested in. You get the full correlation matrix, just as you did in SPSS. A few useful options. No prob suppresses the p-values. No miss drops all missing cases. Alpha computes coefficient alpha. Don't know if you did that with Kallian, but that's a measure of the reliability of a scale. So if you ever need an alpha, you do it in PROC core. A really nice thing with SAS and SPSS syntax, it's not available in the pull-down menus of SPSS, is the with statement. So sometimes you want to compute correlations of some variable with some others. You don't want the full correlation matrix. You just care about, all these variables with these variables. All right, so you can, here is the output. So that's a very useful thing to know about. And that's it for this lecture. On the next slide, there will be your turn, some things for you to practice, and we'll talk about this in class.